In this video, we're going to look at how to find an Euler path or circuit once we determine that one exists. So this uses a method called Fleury's algorithm, and it's kind of a common sense algorithm if you think about it. So first thing we want to do is make sure the graph is connected, and if it's not, we have to stop, and that there are either no odd vertices, meaning they're all even. So that tells us we have an Euler circuit, or exactly two odd vertices, meaning that there is an Euler path. So first we have to go back, we have to figure out what it is that we have. Now once we determine what we're looking for, we need to choose a starting vertex. So when you're dealing with a circuit, they're all even, so you can start anywhere. But when you're dealing with a path, this is really important. Remember, you have two odd vertices, so you must choose one of the odds. So you'll begin at one odd and you'll end at the other odd. If you start at an even, you're not going to be able to get the path to work out. So at each step, don't choose a bridge of the yet to be traveled part of the graph unless it's your only option. I sort of paraphrase this into don't strand yourself. Okay, make sure if you're going to a vertex that you have a way to get out. When you can't travel anymore and you've traveled every single edge, then the circuit or path is complete. All right, so we've got some examples on the next page. So if you look at the top three examples, it says to find an Euler circuit. So what they're telling us is we don't have to go count all of the vertices and make sure they're even. We know that they are all even. Okay, so we already know that we can find a circuit. Instead of starting with this one, since it's the most complicated, let's start with this one on the right. Now, because it's a circuit and they're all even, you can start anywhere you want. Okay, so just pick a starting point. I'm going to use this vertex right here. And my goal is to travel every single edge once and only once. So you may want to pause the video and just try this out. There's usually more than one correct answer. Remember, you can go through a vertex more than once, but you can't visit an edge more than once. All right, so pause the video, and then when you come back, I'll give you a solution. All right, so here's the one I came up with. Since we don't have any letters, what I'm going to do is I'm just going to do numbers. So I started by going this way. So I'm going to label that my first edge. And if you want, you can even put a little arrow to indicate direction. So I'm going to go here, then I'm going to go back down. One of the reasons I started here is I can see these corners. It would be an easy place to strand myself. So I want to get those done first. And then I'm going to go ahead and do 3 and 4. So 3 this way, 4 back this way. So now I'm here, and I still need to travel all of these edges. So I have a couple of options. I could go ahead and go up and do 5. I could go across and do 6. Now I've hit that vertex, but that's okay. I can revisit a vertex. I still need to visit these 3 edges. So I need to trace this triangle. I can go either direction. So that'll be 7, that'll be 8, and then that will be 9. So the idea is you make it easy for someone to follow your circuit. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and I went back to where I started. This is one of many ways to do this particular problem, but just to show you one option. All right, so for the bottom example, we can start anywhere we want. I'm just going to pick a spot. Okay, and so I want to travel every edge once and only once, and then come back to the beginning. I'm going to go ahead and start by going this direction. Now, if you don't want to do the arrows, you don't really have to. You can just do the numbers. So I'm going to go 1, 2, 3, and I'm going to go back up for 4. So 2, 3, 4. So I'm going to revisit that vertex a couple of times, but that's okay. So once I've gotten to here, I'm going to come down. That'll be 5. I'm going to go around this triangle. So 6, 7, 8. Now I'm to here, and I'm going to go 9, 10. So even without the arrows, if I know where you started, I can still trace your circuit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We traveled every edge once and only once and came back to where we started. Now this one's probably the hardest. I'm going to go ahead and start here. So I don't particularly like these spots. These look like a good place to get stranded. So I'm just going to go across the top first. So that'll be 1, 2, 3, 4, 5. That gets me to here. And then I'm going to come down and do this corner. So 6, 7, 8. Now before I move back, I'd like to get all of these edges traveled. So I'm going to do the diagonal. I'm going to go 9, 10, back down for 11, back across for 12, and then up for 13. So I started here, kind of did an X, and that took care of that whole little block there. So now I'm right here. I can't do this edge because I've already traveled it, so my only option is this diagonal. That'll be 14. I'm going to come across 15, back up the diagonal is 16. Now I'm to here. Okay, so I can either go left or I can go down. I'm going to go ahead and go down and go 17, 18, 19. So now I'm to here. I'm going to come across and do 20. Now from here, I've already done all these edges. The only thing I can do is my left diagonal, so that'll be 21. Back across here is 22. Here's 23, and back up is 24. So that is one of many ways you could do that particular Euler circuit. So on your homework, if you mark them, I can trace it and see if it's correct or not. My cat's bringing us a toy. I'm sure you can hear that. She's very excited to bring us a toy. All right, let's look at the bottom ones on these. Thank you, sweetie. Thank you. Thank you. All right, so we're going to do an Euler path. So for the Euler path, we need to be a little bit more careful. We know that if an Euler path exists, that there are two odd vertices. So the trick is we have to find those first because we have to start at one and end at the other. So make a little note, start at one odd, end at the other. All right, so let's start with an easier one. Let's start with this one. So if I start counting, I can see the corners. That's 2. Let's see, that one's 1, 2, 3. So this one's an odd. I don't actually need to mark that. Let me mark that out. That one's odd. This one's got 2. This one has 1, 2, 3, 4, so it's even. This one has 2, and then this one has 1, 2, 3. So these are the vertices I need to start and end at. So I'm going to go ahead and start at this one and end at this one. And you could do the other way as well. So this one isn't too bad. I need to travel every single edge. So there's a couple of ways I could do this. I'm going to go up first. I'm going to go 1, 2. That'll get me here to here. I'm going to go, I guess I could go this way. Yeah, that'll work. I can go 3, 4. That'll get me to here. And then I just need to go around this rectangle. And it doesn't matter if you go clockwise or counterclockwise. I could go 5, 6, 7, 8. And so then I started here and I ended here. So again, there's lots of different correct answers here, but we do have to travel each edge once and only once. All right, let's try this one down here. We need to find our odds. These have 2s, these have 2s. This one has a 4, so it looks like our odds are going to be these little corners right here. It looks like they have 1, 2, 3, 1, 2, 3. So I'm going to go ahead and identify those. And I'm going to start at one and I'm going to end at the other. All right, so a couple of options here. I could go around this triangle, then I could go around here, and I could go around that triangle. That would be one of many options. So I'm going to do that. I'm going to go 1, 2, 3. So that traced that triangle. I'm going to go 4, 5, 6. That traces me to here. Now I'm hitting that vertex, but that's okay as long as I don't revisit an edge. And then I can go around that triangle either direction. So 7, 8, 9. Have traveled every edge, started here and ended here. All right, so our very last one is this one up here. Remember, we do have to identify our odds. This one looks odd, 1, 2, 3. So there's one. That one looks odd. Just to check the others, this one has 1, 2, 3, 4, 5, 6, so it's even. This one has 2, 1, 2, 3, 4, 1, 2, 3, 4, 2, 1, 2, 3, 4, 5, 6. Okay, so I got my odds. So I'm going to go ahead and start here and end here, and you could reverse that if you wanted. So take a second and pause the video, and when you come back, I'll show you one possible Euler path. All right, so here's the path I came up with. And if you want to put arrows, you can to indicate direction. I went 1, 2, 3, and I went 4, 5, 6. So I kind of went around the bottom. That's a 4. 5, 6. Put my little arrows in there. And then from here, I kind of went and did this little box. So I went 7, 8, 9, 10. So now I'm to here. I went back up for 11. Now once I'm here, I've traveled every edge except this one, so I have to come back down. That's 12. I'm to here. And then I can do 13. Back down will be 14, and then back across will be 15. All right, so that's one of many possible Euler paths.